Hello everyone, my name is Sharath and my friends Abdul Afroz and Geetha. We have worked on a project which is microwave oven simulator during our internship in EMERTXE Embedded System internship. During this internship, we have learned many things. Further, we'll be discussing about topics learned during internship, general description of the project, functional requirements, interfacing of microcontroller and various interfacing devices, and finally project demo. Topics learned during the internship: Introduction to C language, conditional statements, loops and operators, arrays and operators, functions and strings, storage classes, Introduction to embedded systems and microcontrollers, MPLAB IDE, XE8 compiler, PICSimLab. Introduction to various peripherals of PIC-16F8-877A. Interfacing various peripherals to PIC-16F8-77A. Microwave oven simulator has 5 screens: power on screen, cooking mode display, setup or temperature screen, issue warning, and end screen. Where power on screen is turning on the microwave oven on, the oven displays needs to display the power on message. Whereas cooking modes has 4 different modes. One is micro mode, grill mode, convection mode, and start mode. Set time or temperature is the oven needs to facilitate the user to input required cooking time or temperature. Issue warning: the oven needs to warn the user in case of invalid time or temperature input or when the door is opened during the cooking time. End appears when the oven needs to display cooking time of message on completion of cooking time. Functional requirements are: once powering on the microwave oven, the CLCD displays the power on message, which is followed by the display of 4 different cooking modes, which are micro mode, grill mode, convection mode, and start mode. The micro mode. On pressing key 1 in the matrix keypad, micro mode is selected. The CLCD displays the power. CLCD prompts the user to enter the cooking time. Star button clears the time, where hash button confirms the time and starts cooking. Time starts, fan starts. Key 4 of matrix keypad add 30 seconds to the current cooking time. Key 5 pauses the cooking time, whereas it pauses timer and fan as well. Key 4 also resumes the cooking and key 6 ends the cooking. Functional requirements of the grill mode. On pressing the key 2 in matrix keypad, grill mode is selected. CLCD prompts the user to enter the cooking time. Star button clears the time, where hash button confirms the time and starts cooking. The convection mode. On pressing key 3 in matrix keypad, convection mode is selected. CLCD prompts the user to enter cooking time. Star button clears the time, where hash button confirms the time and starts cooking. Oven starts preheating with given temperature for 3 minutes, that is 180 seconds, following which prompts the user to enter the cooking time. On pressing key 4 in matrix keypad, start mode is selected. Cooking time is by default set to 30 seconds and the cooking starts automatically. And from here my friend Geetha will be continuing.
Hello everyone, I'm Geetha. Here we can see that interfacing with PIC16F877A. Its main features are it has an operating frequency of 20 MHz, 5 input-output ports, port A, port B, port C, port D, and port E. There are 15 total interrupts, 3 timers, and it has a flash memory of 8 KB and data memory is 368 bytes. As shown in the figure, we can see that it can be interfaced with matrix keypad, SSDs, digital keypad, buzzer, LEDs, GPIOs, EEPROM, and temperature sensor. CLCD. CLCD stands for Crystal Display. It is mainly based on HT44780 display controller. Here in this project, we have used 16 by 4 in 4-bit mode CLCD. It is used to display messages like in calculator, etc. It is connected to port T. Its enable is connected to pin 1 of port E and RS is connected to pin 2 of port E. Matrix keypad. Matrix keypad is a 4x4 matrix where it is used to trigger the commands given by the user. Uh, it acts as a edge or state triggering mode. It is used to select cooking modes and enter time and temperature values. In this matrix, it is connected to port D as rows and port B as columns. In timer 2 is an 8-bit timer with a prescaler and postscaler. The timer 2 register is readable and writable and is cleared on any device reset. Interrupts. Interrupts are used when the microcontroller needs an interrupt. An interrupt occurs when the timer 2 register overflows. Buzzer and fan. Buzzer is connected to pin 1 of port C. It is used to uh, give a signal when the timer goes off. Fan is connected to pin 2 of port C. It is used as a cooler in the microwave oven simulator. Now, my friend will continue.
Thank you, Prabha.
Hello everyone.
Thank you, Prabha.
Hello everyone. Now let us see the implementation of microwave oven simulator. Now here we can see the microwave oven folder which consists of various header files, linker files, source files, libraries and important files. Here the header files are the files which declare the function basic uh, functioning types and each functioning of the source is given in this file. For example, if we see the CLCD, as we can see that here the header file consists of various functions that have been declared by the interfacing devices. For example, if we see the CLCD header, here we have different the input and output ports of the CLCD display and the functions that are to be declared uh, in the CLCD or the main function for the proper functioning of it. Here as you can see we have defined 8-bit mode, 4-bit mode, 2 lines 5 cross 8, 4-bit mode, clear display. And these are line 1, line 2. These are the input and output ports that are bit connected. Now if we go to matrix keyboard, the matrix keyboard consists of rows and columns. Here the separate rows have been declared and here separate columns are being declared. If a particular key is pressed, then the value of that particular matrix will go high or else it will go low. Here the state declares whether the key push is at high or low. Now the timers. The timers are used for declaring the amount of time or the temperature that is being set by the user and finding whether the time has completed or not. Now the source files. The source files are the main embedded C files which gives the proper functioning in the interfacing. Now the CLCD file has the functions which has been declared while interfacing PIC controller in the functions that are being declared. The matrix keyboard function, for example, like if column 1 is at low, it returns value 1, and if column 2 is low, it returns value 5. Like this, for every row and column, the functions have been declared. Main. Here, the main function is the most important function of all. All the headers and the source files are being called and declared in this function. The functioning, for example, if we in set time here, if the reset flag is being clicked, then the microwave returns to its original state. If the key hash is pressed, then it clears the time, and if the key hash is pressed, then it confirms the time. If there is no place, if there is no key is pressed, then all the states have been released. Now here we are going to declare one more function which is called as ISR, interrupt service routine. Interrupt service routine is a function which is being called when an unwanted interrupt is occurred. An interrupt is a function uh, which occurs when there is an overflow. So this function has been declared when the timer or the temperature given overflows or the invalid function or the invalid temperature of the time. Now let us build a microwave oven. We can build this by clicking on the microwave oven project folder and clicking on build. As you can see, the project is being built. Here the message build successful confirms that there are no errors in the source and header files. Now we need to now the hex file is being generated by the IDE. The the hex file location is being given here. Now we need to copy the location uh, to for the implementation of the simulator. We need PICSimLab. This is the PICSimLab interface. When we open the simulator, the basic board which shows is the Arduino Uno. Now we need to specify the board. Here we use PIC Genos, which consists of all the PIC microcontrollers. Here the microcontroller which we are going to use is PIC16F877A. After loading the microcontroller, we need to import the hex file. For importing the hex file, we need to click on File, Load Hex. After opening, we need to declare the location that is being copied previously. Yeah, this is the hex file that is being generated by the building of the microwave oven project in the MPLAB. Now we need to load it. Here you can see the project has been loaded and the microwave oven display the powering on. Yeah, the cooking modes which are being given in the function are displayed here. The matrix keyboard displaying here are used to select the cooking modes and the other options. For example, if we want to select the micro mode, the key 1 of the matrix keyboard is being clicked. Here the power 900 watts is being set. Now we need to declare the timer. For example, if we gonna declare the 10 seconds, 1, 0. So the timer is set for 10 seconds. For entering the value, we need to press the key hash. The timer has been started. If we press the key 4 now, additional 30 seconds have been added to the timer. Now if we press the key 4 again, it adds additional 30 seconds. Now if we press key 5, it pauses the timer. See, as you can see, the timer has been paused as well as the fan. Here the fan acts as a heater and a cooler. If we press key 6, then the total operation will be stopped. Like for example, yeah, so you can see the total operation has been stopped. To resume it, we can press key 4. Yeah, press, now it has been declared the stop. It has returned back to the cooking mode. For example, if we go to the grill mode, now we are going to declare a time of 10 seconds. Pressing hash to enter the value. As you can see, the fan has started. Hence, the cooking mode has been started. When the timer reaches 0, it pop-ups the time display. As you can see, the time up has been displayed, which means that the set time has been done, and it returns back to uh, the cooking modes. Now, if we go to the convention mode, now in convention mode we can declare the timer. Now let us declare a timer of 200 degrees Celsius. Yeah, as we have declared 200 degrees Celsius. Here the preheating is being done such that the temperature inside the oven can reach the user defined temperature. Now, as we have given 200 degrees Celsius, the preheating will make the inside area of the oven to 200 degrees Celsius. As the time reaches 0, we can set the timer for cooking. As you can see, it has been heated to 200 degrees Celsius. Now, let us start for 10 seconds. As you can see, the timer has started running, means the cooking is being done at 200 degrees Celsius for 10 minutes, for 10 seconds. Time is up, means the cooking has been done. It returns to its original state. This is the working of the microwave movement simulator using PIC microcontroller. I thank EMERTXE for providing us this internship and providing the basics of PIC microcontroller, which helps in the growth and learning of for the embedded systems. Thank you.